Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 8 in our incredible new tutorial series where you're knowing where you're going using your ultimate GPS tracker project. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And in addition to getting your coffee, I also will need you to get out your most excellent GPS tracker project. And you can see mine here. At this point, all we really have hooked up is just the Raspberry Pi Pico W to the Adafruit Ultimate GPS version 3. So we need you to get that back out. And what we're going to do is we're going to start where we left off last week. And what I'm going to need you to do is go over to the most excellent www.toptechboy.com. I'm going to need you to search on something using this happy little search bar here. I'm going to need you to search on something like Raspberry Pi Pico W GPS tracker using 2 cores with threading. And then we're going to come down here and we are going to get this code, which is the code that we left off with last week, the code that we ended up with last week. And then we'll come over here. Let's see. I need to do a tad bit of Windows management. I should have had this window resized before I started the video. I don't know, do you guys ever have this thing where you just can't quite get the corner of the little window? Let's see here. There it goes. Okay, that should be good. Come up here like this. Okay, one more little adjustment. Okay, like that. And let me see if I can bring this down just a little bit. Okay, apologize for wasting 37 of your seconds there, but we're going to start with that code that we ended up with last week. Now, what did we do last week? Last week, we learned that the real issue in using a component like the Ultimate GPS is that it communicates over UART, and all this thing does is just sit and throws data at you. It doesn't listen for you. It just sits and throws data at you. And so what happens is that data goes into a buffer. If you're not constantly reading the buffer will fill up, and then any new data will be lost. And as the buffer fills up, that last little bit in the buffer is going to be a partial NMEA sentence. And then when you try to parse that, you're going to, in some unexpected way, crash your program. So what we did last week is we developed this most excellent program where we use both cores. One core simply reads in and forms the NMEA sentences and puts the NMEA sentences in a dictionary, and then the other core makes a copy of that dictionary and goes out and does whatever you want to do. Now, last week it was a pretty big chore just to get that dual core thing going and the reading of the NMEA sentences and the creation of that dictionary, so we just sort of stopped there. Now, what your homework assignment for today was to go in and now parse those NMEA sentences where you get useful information out of them, like latitude, longitude, heading, knots, how fast you're going, and number of satellites, and useful things like that. That was your homework assignment. So I think I should ask you guys, were you successful? If you were successful, leave a comment down below. I am legend. Double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Okay, now in this class, I am assuming that you already took the Raspberry Pi Pico W class, and so I'm not assuming in this class that you are an absolute beginner. I'm assuming that you have a little experience under your belt. But if you struggled with the homework, don't worry about it. I am going to show you my solution right now. Okay, so let's come over here and let's make sure that this code is working and that the universe is in the proper working order. And so let's just run this and see what happens. Thread running. Okay, we got the junk coming out, and then where is anything else? I think I'm waiting 10 seconds in the way that I did this. So you'll get the first NMEA sentence after 10 seconds. Yeah, there's the first NMEA sentence. And so things do seem to be properly working. If I look at it, we've got a fix. And so everything is in proper order. And remember, we have that clean exit with a Control C. You kill the thread and then you turn off the UART and you cleanly leaving everything in proper order. Okay, so that's good. Now, I do believe that I have one little error last week, and it didn't really bite us last week because we didn't really use this part of it, but somewhere instead of GP RMC, in one of those places, maybe I already corrected it on the website, but I think where I had GP RMC up here, I had GM RMC. And so just make sure that you are using GP RMC. And I think what I did was, I think I already corrected that on the website. But if you are using last week's program, make sure that you spelled GP RMC right and that you didn't just blindly copy what I was doing, because I think I had a little bit of an error in there. Okay, so this is our strategy. The thread, which is defined GPS thread, that function, that thread runs on its own core, and we're not going to do anything else on that core. The new function that we develop, which is going to parse the NMEA sentences, we're going to run that on the same core as the main loop right here, the main loop down here that's just sitting, and at this point it's just reading the main NMEA dictionary and then printing out the GPGGA NMEA sentence from that. Okay, so what we are going to do is we are going to do everything outside of this thread function, and that will put it on our main core that the main program is running on. So all of this is going to not be changed. We're not going to add anything to that. Now, one thing we are going to do is we're going to give this thread a chance to start, because what I found was I ran into a couple of unexpected scenarios, because I would kick off the thread and then I would jump down and start reading the dictionary before the dictionary maybe in all cases had a time to be formed. And so I'm going to start the thread and I'm going to give the thread 2 seconds to run before we jump down here. So hopefully that makes sense. Now, right now we have our NMEA data, which is the main dictionary that is created inside that thread. And then when we come down in our main loop, we create a copy of that main dictionary that we're using here locally. And we make a copy of it so we can release it back to the other core, back to the thread that is forming the dictionary. Okay, so we lock it, we grab it, we lock it, we make a copy of it, we unlock it, and then we do all of our work with the copy, okay? And we sort of defined the main dictionary up here like this, okay? Now, what we need to do is we need to create a new dictionary, and instead of that new dictionary is not going to just have those rather unfriendly NMEA sentences, but we're going to bust up and we're going to parse the NMEA sentences, and then we're going to have a nice user-friendly dictionary, and that user-friendly dictionary we are going to call GPS data. Okay, and GPS data is going to be a dictionary, and what it is going to have is it's going to have the actual data, the user-friendly data that we want. And so in the dictionary, I am going to have an index or a key of lat DD, and that's for decimal degrees. And I think I'm going to tab over, and that is just going to be set to 0 initially. I'm trying to put values in here so if I'm looking at it or trying to split it before it's actually got the data from the GPS, that the program doesn't crash. Okay, so I'm just putting in placeholders for the data, lon dd, and that that is going to be 0 as well. All right, and then what do we have? We are going to have the heading, what direction we are headed if we are moving, and that is going to be 0 degrees. And then we are going to have, do we have a fix? And so we have the index of fix. And then what that is going to do is I'm going to have that be false. Okay, because when you turn it on, you don't initially have a fix. Now, I have to tell you, on that GPGGA sentence, the fix is given like as a 0 for no fix, a 1 if you have one type of fix, a 2 if you have another type of fix. So there's all these different types of fixes, and I'm going to just boil that down to either true or false. I don't really care what kind of fix we have. All I care about is, do we have a fix? So I'm going to make fix a Boolean of either true or false. Now, how many sats do we have? The number of satellites is going to be set to 0 initially, and then knots is how fast we are going in nautical miles per hour. Okay, and then that is going to be a 0. A 0 like that. And then I'm going to come down, and I think that's got everything, so I'm going to close that dictionary. Okay, so now I have the dictionary. All right, is there any other things that I need to do up here? I've got my threading going, all that should be the same. And really mainly what we are going to be doing, is right down here, what we are going to do is we are going to create a new function. Okay, we are going to create a new function, and that is going to be what parses the GPS. Okay, so right after we finish that thread, what I'm going to do is I'm going to define a new function, which is parse GPS. Okay, now like that. Okay, now a couple of things. Since I defined this down here, this NMEA main, which is what we're going to be using up in the function, since I defined it up in the function, since I defined it in this main loop, then the function should know it. So if I'm thinking about this right, that should be sort of like a born global. That should be like a born global dictionary, which means I don't have to define it as global up here. Okay, now here is the tricky part. Right when you turn the project on, when you power it up, you might not have even pulled in an empty dictionary yet. And even if you did pull in the dictionary, like you populated it with just blanks or zeros or whatever, you might not have a fix. And if you don't have a fix, then a lot of those different positions in the NMEA sentence are going to be empty. So we don't want to parse the NMEA sentence unless we know we have a fix. But to figure out if we have a fix, we have to look at the NMEA sentence. And so what I'm going to do is I'm going to have one rather awkward line here that's going to look into that data and just look to see if we have a fix. And if we have a fix, then we'll go and we'll parse. And if we don't have a fix, then we won't do that, okay? But remember that initially we set it as no fix. So the only way it'll get a fix is if we see in this line of code that it has a fix, and then we drop into the if statement. Maybe it would make more sense if I just did it. So I'm going to read to see if we have a fix. Okay, now how am I going to do that? I need to go to our main dictionary, the NMEA main, and that's our local one, the one that we made a copy of down in the main loop. All right, and now what do I need to look at? I need to look at in that the index, the key GPGGA, all right, and that position in the dictionary. All right, and then that position is going to be a whole NMEA sentence, a very long string. So what are we going to need to do? We are going to need to split that string on the comma. Okay, and so now I've got the GPGGA NMEA sentence, and remember the 0th position is just the label GPGGA. The next one is the time, the next one is the lat, the next one is like north or south, and the next one is the lon, and then the next one is the east or the west, and then the next one is whether you have a fix. Okay, so that would be the 6th position. Okay, and so now I have read that 6th position. It will either be like a 0, a 1, a 2, or something else. But if it's a 0, you don't have a fix. So now I'm going to say if read fix is not equal to 0, then that means you have a fix. Okay, so I just want to kind of do this to see if this is going to work. So I'm going to say print here. I'm going to print read. I'm going to print read fix, and then comma read fix, like that. Okay, because we just want to kind of see if this is going to make sense, right? We just want to see if this is going to make sense. And one thing I think that we better do here as well, something that we better do here as well, that this this read fix right now might very well be a string. So I think I better make this whole thing an int. Okay, because the whole thing is a string, and then I am splitting it, and then when I split it, I would end up with a little bit of a string there. Okay, so I think I need to make it an int, but let's check and see what happens here. Okay, so let's run this thing. Okay, there is the junk. Okay, and now it is getting a NMEA sentence, and then it never got down in here. Okay, if it's not equal to 0. Okay, so it's a surprise result that we didn't get in here. All right, I know why we didn't get in here. Control C. Because down here, we need to do a little work down here. We have defined the function, but here in our main thing here, we're going to acquire the lock. We're going to get our copy of the dictionary. We are going to release the lock. Okay, we're going to release the lock, and then we are going to parse GPS. You see, I never called the function, so we're going to parse GPS, and then the other things can be the same. Parse GPS. All right, so let's run this again. Let's Control C out of here cleanly, and now let's see if it gets in there. Thread running. Okay, there's that. Okay, good. Look at that. It says the read fix is 2, so that means that it that means that, where were we? Okay, right here. That means that read fix, it read it as a 2, and because 2 is not equal to 0, then we ended up in here. Okay, so hopefully that makes sense. Now, I don't want to really print that. I just wanted to kind of make sure that the program was flowing like I wanted it to. So that looks pretty good at this point. So now, if we have a fix, which means the fix is not 0, then we want to come in, and what we want to do is we want to start parsing our NMEA sentence. Well, one thing is GPS data, that's our new dictionary, the index affix. What is one thing we know at this point? We know if we got in here that this is true. We have a fix. Okay, now the next thing I want is the latitude raw. Okay, the latitude raw, the raw latitude data. This is the latitude data that comes off of the NMEA sentence. Well, that is going to be equal to NMEA main, and that is our copy of the NMEA dictionary. Okay, NMEA main. Which sentence has that? It is the GGA sentence, so that I put in as my index. Okay, I want to split that at the comma. After I split it, what position do I want? The 0th position is the label GPGGA. The first position then is the time. The second position is the raw lat, okay? And that raw lat, so I take the second element out of that sentence, okay? The second element out of that sentence. And then I might as well go ahead and get lat DD for decimal degrees. Okay, now what do we know? What do we know? We know that this is in degrees decimal minutes. And a couple of weeks ago, I went through this in detail, so I'm not going to go through it in that level of detail. But the first two characters are what? The degrees. And so I'm going to take the integer value of lat raw that we just did, and I'm going to go from the 0th position, okay, up to but not including the second position. So in that decimal degrees, this is going to be get the 0th and the first, and those two digits are the decimal, or those two are just the degrees, the number of degrees. So now I have the number of degrees, right? And now I want to plus that with a float of the lat raw. And I want to go now starting at 2 all the way to the end. And then that is what? That is the decimal minutes. That is the decimal minutes. So I want to change that to degrees. And so if you go from minutes to degrees, you divide by 60. All right. So this now should give me the latitude in decimal degrees, if I'm thinking about this right. Yep. 0 to 2, int, float, lat raw. Okay, and let's just do a, I didn't close something. Okay, int, that should close. Something is not closed. Maybe it is up here. I've got an error here. Do you guys see it? Split 2, dot split GPGGA, lat raw, lat DD, int, lat raw. I need to close the int. Okay, so I close the int, open the float, close the float. All right, so now let's do just a real quick print lat DD, okay? And we know that I should be like a 0.4 something. So let's just see what happens here. Okay, look at that. You see, that is a pretty good, I think that should be my latitude correctly. So I really think that we have that right. So I'm going to do Control C, and then we don't need to print that. Okay, we don't need to print that. But what do we need to remember? I am what? I am in the northern hemisphere. For you guys in the southern hemisphere, we're going to have to, I think I'll just take this, this whole thing here because I'm tired of typing it in, and we're going to have to bust that up again. But if that GPGGA sentence that's been split and the third position is going to tell you either north or south. And if you are a south in the S, I'm an N. If you are in the S, what do we need to do? Lat DD equal minus lat DD, like that. Okay? So now, what do we need to do? We need to now put that in our GPS data dictionary. So now I'm going to put GPS data, and this time it is going to be the key lat DD, like that, and then it is going to be equal to lat DD. All right, and if you're in the southern hemisphere, it has been corrected. All right, now the next one is going to be ln raw. Okay, ln raw, and I am going to get the lat raw and live dangerously, and I'm going to paste that, and that is going to be, instead of the second position, right, the second position is the lat raw, the third position is that north or south business, and then the fourth position is the ln raw. Okay, now what I am going to do is the ln DD is going to be equal to almost this same thing. Okay, almost this same thing. Okay, but it is going to be ln raw and ln raw. And what else do we need to change? The 0 to 2. Remember, in the longitude, we could go up to 380. We could go up to like 360. You could go from 0 to 180 or 0 to minus 180, even though the negative business is going to be handled by east or west, but there are 3 digits because 180 or 179 would be 3 digits. So we're going to go 0 to 3, and then we would start at 3. And right, this is up to 3, but not including it. So 0, 1, 2 would be 3 digits. And then the third digit is we don't go to, and we start with the third digit here. Okay, does that make sense? Okay. Now, if, and then it's going to be almost the same as this, right? Almost the same as this. Okay, split, but instead of the third position, okay, let's see here. This is going to be, if it's west this time, GPA split of 3, and this one up here on this if statement, I got to think, because these both wouldn't be 3. So let's think. 0 is the label, 1 is the time, 2 is the latitude, and 3 is the north or south. And then here, 4 is the longitude raw. So this would be 5. So if 5 is equal to west, I think that will work. And in that case, ln DD is equal to minus ln DD. And so what we're doing is, the NMEA sentence doesn't have plus and minus degrees. It just uses, you know, north is plus. If it's north, it's plus. And if it's south, it should be minus. And same thing, east and west. You see, east should be positive and west should be negative. And so that is what we are doing there. Okay, now we need to go ahead, and now we need to put that in GPS data of ln DD, like that. Okay, and that's going to be equal to heading. All right, I'm just going to run this just to see if we have any errors. It shouldn't really be doing anything. Okay, heading isn't defined. Okay, I see what I did. All right, so ln DD should be ln DD. I was thinking about the next thing that I'm going to be reading in, and I was getting ahead of myself. That's why it's good to check as you're going along. Okay, we're making our way through this. Now, we're going to say that heading is going to be equal to, again, I'm going to get this big thing here. Okay, and then we'll customize it for this case. But heading is going to be equal to the float of that busted up NMEA sentence, okay, and we're going to split it. And this time the heading is not on the GPGGA sentence. If you remember that lesson a few weeks ago, it is the GPRMC sentence, and it is over on the 8th position. And I don't know if we can see a GPRMC. Yeah, here's a GPRMC. Let me get out of your way here. Let me get all the way out of your way. Here is the GPRMC. GPRMC. This is the 0th position, the 1 position, the 2 position, the 3 position, the 4 position, the 5 position, the 6 position, the 7 position, and then this 8 position here, that is the heading. Okay, that is the heading. If I'm thinking about this right, the heading is the 8th position. Let me count that again. This is 0. No, this is 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, yeah, so that says that that is the 8th position, if I'm looking at that right. Okay, so I've got that in the 8th position of the GPRMC. All right, so now I floated that. Now I need to get the GPS data. What do I have now? I now have the heading, and that is going to be equal to the heading that I just calculated. Okay, that just sure, I don't like this number, but this was kind of one of those junk ones that I threw away. But this, I think, is supposed to be the heading, and then this is supposed, oh yeah, and I'm sorry, heading can be anything, right? Heading can be anything. And then this one is the knots, which is the, you know, we're standing still, but it's reading it at like 1 knot, which is just the measurement error. Okay, and so this is all very good. So now what we're going to do is we're going to say knots is going to be equal to, we will get this one because it should be almost the same as that. Okay, it's also the GPRMC split, and we saw that the speed, the knots, is at 7. Okay, and so now what we're going to do is GPS data of knots is going to be equal to what? Knots. All right. Now we also want the sats, the number of sats, and that is going to be back up to like this one here. We'll copy that. Okay, we're going to paste it, and it's the GPGGA sentence split at the comma, and it is not the 4th one. The sats is GPGGA 7. Now you're going to say, hey, I thought that the knots was 7. No, the knots is the 7th position of the GPRMC sentence, and this is the 7th position of the GPGGA. So let's look at this. GPGGA, this is 0, 1, 2, 3, 4, 5, 6, 7, and 7 in the 7th position is unusual, but that is then the number of satellites, which is 7. Okay, and now what I'm going to do is GPS data of sats. How many sats do we have? And that's going to be equal to sats that we just got. All right, let me stop being a munchkin there. All right, so now Let's run this thing and see if we have any errors. Okay, it's running. Okay, and now I'm getting GPGGA sentences because while I am parsing the data, I'm still just printing GPGGA. But you notice, look, it's working properly like 17 seconds, and then 10 seconds later, I got the new GPGGA sentence, and then 10 seconds later, the new one. And so I'm getting fresh and complete NMEA sentences, and so that's good. Everything is working so far like it should. But now the real question is that are we getting clean data? Did I make mistakes in parsing that data? Okay, did I make mistakes in parsing that data? And so what we want to do is now, at this point, since we have parsed the first set of data, we should know whether we have a fix or not. So I'm going to say if GPS data of fix, like that. Okay, if that's equal false, what does that mean? When it came up here, okay, it did not read that as a true, so it never ended up in here. It didn't read it as a 1 or a 2 or whatever. It read it as a 0, so it never ended up in here. And so it never got set to true, so it is still stuck on false, which means what? It means that you don't have a fix. So if that is false, we're just going to print waiting for fix. Okay, like that. All right, waiting for fix. But now you notice I don't use an else. I've never used an else in my life. If GPS data, because I think it's a double negative and I think it creates confusion in people that are looking at your code. So if GPS data of fix is going to be equal true, that means you have a fix that you got in that down below. Then what are we going to do? We're going to print the ultimate GPS tracker report, like that. Okay, we're going to print the ultimate report. I'm going to print lat and lon, like that. Okay, and then what do I want? I want GPS data of what? GPS data, our dictionary, our data dictionary of what? I want lat dd. Okay, and then I want what? GPS data, all right, of lon dd, longitude. Okay, now why did I do it this way where I said lat and lon is this comma this? That way I can do one copy and then I can paste it into Google Earth. Okay, I can do one copy and I can paste it into Google Earth. All right, so that looks good. That looks good. All right, let's run this thing. So I'm going to Control C to get that to terminate cleanly. And let's run this thing. Okay. Right, and I got a GPGA sentence because I forgot to stop printing that. So let me Control Quit and Control C, and let me take this print out, and now let me run it again. Okay. Okay, so now I'm getting lat lons. Let me just copy this like this. Because you see, I very well could have parsed that wrong. I could have made an error in there. So I really want to check it. And the way I will check it is I will come over here. And you can see on Google Earth, there is this search for a place. So I'm going to Control V into that. And then let's see. I want to start in some random spot. Okay, and now what I've done is I put the lat long that I copied, right? I copied that lat long from the GPS program, and now I'm going to search on it. Okay, and we are coming over here and getting closer, 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 and boom, look at that. Okay, now I am actually right here, so I am a few meters off. I am a few meters off, but I think, let me go back and just make sure that I did that calculation right. Okay, I want to make sure that I did that calculation right, and I want to just make sure that that is in fact a little bit of uncertainty in the GPS and that I haven't introduced an error in here. So the thing that matters is the lat and the lon, and this was lon raw. Okay, this is lon raw is position 4, okay, and lat raw is position 2, so it's 0, 1, 2, that's right, and then 3, 4. Those two are right on the GPGGA sentence, and so 0 to 2, 0 to 3, lon raw, lat raw, and then lat raw and lon raw from 2 on, from 3 on. Yeah, I think that those are indeed correct. And I just got a couple of meters error in my position as I'm sitting here inside. I've got a lot of electronics around. I will hope that we will get a little bit more accurate than that than when we move outside. Okay, so we've got that going. Let's go ahead and kill this program. And now we want to go ahead and we want to print out some of the other things. Okay, and so let's come down here. So I've got my lat long printing, and you saw how nicely I was able to copy and paste that. So now print, and what do I want? I want my knots, and I sure hope that comes very close to 0, right? I sure hope that comes very close to 0, and that's going to be GPS data of what knots, like that, and then close that, and then close that. I think that looks good. All right, now I'm going to print, and this time heading, and then that's going to be GPS data, and that's going to be heading is my index. Okay, and then I'm going to print. I didn't close that. Okay, now I'm going to print sats, how many sats I have. Okay, like that, comma, GPS data, and then sats. Okay, now I like to print. Let's just try to print a blank there and see what happens. Okay, now guys, I'm going to see if I can make this a little bit bigger. Okay, and now we are going to run this thing. Thread running, we get our junk, and then look at that Ultimate GPS tracker report. Lat lon 0 and 33.16 knots is 0.73. That makes sense because we are not moving. And then heading is 342 degrees. That's a random number because we're not moving. It's just something between 0 and 360. And then the number of satellites is 7. Let's get this and see if it's any more accurate on the Google Earth. Okay, let's get this and see if it is any more accurate on the Google Earth. And so I will put that new value in, Control V. And yes, guys, I am showing you where my house is, but as I've said before, okay, boom, look at that, right? Really, really precisely that right here is my office, my studio. And so you see, like you see the river behind me, that's out the window there. Okay, so yes, that is very, very accurate what we are getting now. All right, and then 7 satellites is good. So guys, we're not gonna be able to really check how well we're doing on the heading and the knots until we go out and we actually start moving with this thing. But I would say that we had a successful day today. Okay, guys, I really, really need you to be leaving comments down below. I need you to be telling me, hey, my soldering went well. The thing booted up, or my soldering destroyed the board, or I booted up but I just cannot get a fix, or I'm getting a fix but it's slow. You got to kind of tell me what's going on, because things are going pretty well for me, but I don't want to, you know, I make these videos and then I don't want to learn that 50 of you guys are just not able to figure out how to get a fix or something like that. Okay, now we are going to talk now. What are we going to talk about? We are going to talk about your homework. Okay, we are going to talk about your homework. Okay, I have got the homework for you to look at, and what your homework assignment is to come in and add the OLED. Okay, so I've got the GPS hooked up and now I'm adding the OLED. Now I have two buttons here, but you don't need to put those buttons on yet. The one thing I will say about the OLED is I will tell you that, remember I was saying sometimes I have trouble getting a fix when I run my GPS at 5 volts and at 3 volts. So I'm getting 5 volts from the USB connector, which is that pin. The USB goes directly to pin 40, that's the V bus. So I'm powering this up with pin 40, which is 5 volts, and then I am powering the GPS up at 5 volts down here. But since the Raspberry Pi Pico W in communication and I2C is a 3.3 volt device, I am powering the OLED by coming around the corner and coming back over here to the 3.3 out, which is pin 36. So I'll just give you a little bit of a heads up there. But you see what I've done is I've taken the program that we've just developed and I've added a little OLED screen, and that is your homework for next week, because you can see what are we trying to do here. We are on our way to creating a mobile unit that we could walk around with or drive around with, and that's the direction we're heading. And next week what I want you to do is put the OLED display on there. Okay guys, I'm trying to break this thing up into meaningful little chunks, and so I hope that I'm not overwhelming you and I hope that I'm not boring you, but I'm kind of trying to give you a nice half hour to 45 minutes every week. I really need your feedback down below so that I can know how I should steer this. If it's overwhelming you or if it's boring you, you need to kind of let me know where we are. And it is also at this point that I always give a big shout out to my friends on Patreon, okay, who are standing with me and supporting this channel. The only way that I can continue to produce quality, in-depth content every single week is with the support of the Patreon. So thank you guys, I really appreciate it. You can also help this video by giving it a thumbs up and leaving a comment down below. That will help with the old YouTube juice. If you haven't already, subscribe to the channel. When you do, make sure that you ring that bell so that you will get notification when future lessons drop. And most importantly, share this video with other people, because the world needs more people knowing where they're going and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.